Hello there, welcome to Dan is Smart. Ever feel like derivatives are getting a little tangled? Don't worry, that is just the chain rule in action. In today's video, I'll show you how to break down even the most complex composite functions step by step. By the end, you'll be a pro at unraveling these tricky derivatives. So basically, the chain rule is used to differentiate composition of functions, right? So we always use this rule. We have dy dx. This is always equal to dy du multiplying du dx. This is what you have to keep in mind. Remember, this du can cancel this, so you just have dy dx back. So basically that's the idea. So without wasting much time, let's quickly try to use the chain rule to differentiate. So we have to differentiate if you have this. Now how do you differentiate this? Remember, to differentiate this, you can use the power rule that we've already gone through, but if the question states emphatically to use the chain rule, how do you use it? Note, to use this, we always represent what is in the parentheses by u. So in this case, we have u to be 3x squared plus 1. If u is that, then it means our y will be equal to u to the power of 2. So since this is a function of x, we can differentiate u with respect to x. In this case, using the power rule, if we differentiate 3x squared, we have just 6x. If we differentiate 1, it goes to 0. And this is a function of u. Excuse me. So if we differentiate this with respect to u, you have 2u. Now using the chain rule we wrote over there, we know that dy dx is dy du multiplying du dx. So in this case, what is dy du? Dy du, we had 2u, and the u dx was 6x. Note, our u is 3x squared plus 1, so we can have this squared plus 1, then multiplying 6x. So if we distribute 2, we have 6x squared plus 2 multiplying 6x. And if we distribute the 6x, we have our dy dx to be equal to 6x squared multiplying 6x, that is 36x cubed. Then 2 multiplying 6x, we have 12x. So this is how you can use the chain rule to solve a problem like this. Now let's look at a second question where we have y equal to sine of x squared plus e to the x. Always remember that your u is what is in the parentheses. So in this case, we have x squared plus ex. So we can rewrite y to be sine of, remember, all of this is u. So we have just sine of u. So to differentiate this is a function of x. So we have du dx. If we differentiate x squared, we are going to get 2x. And if we differentiate ex, you get the same thing. And this is a function of u. So if we differentiate y with respect to u, sine of u, you get cosine of u. So remember, dy dx is dy du dot du dx. So in this case, our dy du is cosine of u, du dx is 2x plus ex. So we can have cosine. Now u is x squared plus ex, multiplying 2x plus ex. So that is dy dx. I hope and this is also clear enough. Let's quickly move on to a third question. So what if you have e to the power of cosine of x? So in this case, your u, whenever you have this, your u becomes your exponent. So if you rewrite y, you have e to the u. Now, since this is x, you have to differentiate with respect to x. And if you differentiate cosine of x, you have negative sine of x. This is u. So if you differentiate y with respect to u, you have u to the u is just the same as something like, it's similar to something like u to the x, right? So if we differentiate this, you have to get the same thing. So you have u to the u. So you have dy dx. This is equal to dy du multiplying du dx. So dy dx, remember dy du, we had e to the u, and du dx we had negative sine of x. So if we multiply these two, we can bring the negative outside, e. Now our u was cosine of x, and then we have sine of x here. So this will be our answer. What if we have a question like this? Y equal to 5x cubed minus x4 to the power of 7. So in this case, as we've been doing, let your u be what is inside the parenthesis, 5x cubed minus x to the 4. So if you do that, your y will become u to the 7th. So in this case, we have du dx. If we differentiate this, we get 15x squared. And if we differentiate the second term, we have negative 4x cubed. Now, if we differentiate y with respect to u, over here, using the power rule, we have 7u to the 6th. So we have dy dx to be equal to du dx dot dy du. So in that case, du dx, what did we get? We had 15x squared minus 4x cubed. Then dy du, we had 7u to the 6th. So we can have 15x squared minus 4x cubed multiplying 7. Now what is u? Our u is 5x cubed minus x4, now to the power of 6. So we can bring the 7 outside. So we have 7. Now we have 15x squared minus 4x cubed. Then over here we can have 5x cubed minus x to the power of 4, then to the power of 6. Let's move on to another question. Let's look at question 5, where we have y equal to 1 over 3x minus 2. So in this case, we are asked to use the chain rule. Remember, we could have used the quotient rule or even the power rule, right? So we can rewrite this as y equal to 3x minus 2. Note that any 1 over 3x minus 2 is the same as writing the reciprocal of it, which is just this. Now, using what we've been doing so far, we will let what is inside the parenthesis be our u. Then we can have y to be equal to u to the exponent of negative of 1. So if we differentiate u with respect to x, we just have 3, and dy du, remember, if you are differentiating using the power rule, the exponent comes down, you subtract 1 from the exponent, so you have this. So this is basically -1 out of u squared. So now the y dx is just the y du multiplying the u dx. So this is equal to, now the y du, we had -1 out of u squared, and the u dx we just had +3. So if we multiply these two, we have -3 out of u squared. So the y dx is -3 out of, now u is what we had over here, 3x minus 2. So in this case, we have 3x minus 2 all squared. I hope this is also clear. Let's look at the sixth question. So for question 6, we have y equal to 5 cosine -4x. How do we solve this question? Any idea on how to go about this? So with this question, whenever you have something like this, right, you can represent your u to be the function that we are considering, right? So we can just have cosine of our x to be your u. In that case, if we are rewriting, your y is 5. Now we said cosine of x is equal to u. So we have u. Remember, cosine of x has an exponent of -4. So we have -4 over here. So now if we differentiate u with respect to x, remember, if we differentiate cosine of x, we have negative sine of x. Now to differentiate y with respect to u using the power rule, -4 will multiply 5, so that gives us -20. Then we subtract 1 from -4, so we have -5 here, which is basically the same as -20 out of the exponent 5. So we know that the y dx is equal to the y du multiplying the u dx. So in this case, our dy du is -20 out of e to the 5 times the u dx is negative sine of x. So now if we multiply these two, negative and negative goes away, so we have 20 sine of x out of e to the 5. Now we know that u in this case is cosine of x, so we have cos 5 of x. So that becomes your answer. So choosing the u is very critical. So in this case, you don't choose u to be cosine -4. If you choose that, it's impossible to solve the problem. So what you do is you just consider the function that you want to differentiate. Okay, now let's move on to the next question. For the next question, we have to differentiate x squared sine to the exponent of 4x plus x cosine of -2x. So how do we solve this problem? Note that with this, we can choose to break this into two parts. So you can have part 1 and part 2. So let's consider the first case. For part 1, let's assume we have y equal to x squared sine exponent 4x. Now, to differentiate this, remember, since we have two functions, right, multiplying, we can use the product rule. So in this case, your f is your first and your g is your second. So if you find f prime, note that we have 2x. Now to find g prime, that is where the problems comes in. So in this case, using the chain rule as we did before, what do you think your u is going to be using the chain rule? Your u is just sine of x without the exponent. Now rewriting it, your g now becomes u to the 4. So if we differentiate u with respect to x, if we differentiate sine of x, you have cosine of x. And if you differentiate g with respect to u using the power rule, you have 4u to the third. So in this case, to find the g over the x, which is the same as g prime, this is equal to the g du multiplying the u over the x. So we have our g prime to be equal to, now the g du is 4u to the third, and the u dx is cosine of x. So we have g prime to be equal to, now what is u? U is sine of x cubed. So that is sine cubed of x times our cosine of x. So now this becomes our g prime. So all that we have to do is go back over here to do our substitution. So we have y prime to be equal to our f, which is s squared, times g prime, which is 4 sine of cubed x cosine of x, then plus your g, which is sine of 4x multiplying f prime, which is just 2x. So we can simplify this to 4s squared sine cubed x cosine of x plus 2x sine 4x. I hope this is clear. So this is for part 1 of the question. So now after solving part 1, let's consider part 2. So for part 2, we have y equal to s cos negative 2x. So in this case, using the product rule, because we have this and this, using the product rule, we have f of g prime plus g of f prime. So in this case, our f is x and our g is cos inverse negative 2 of x. So if we differentiate x, you get a constant, which is 1. Now to differentiate g, we have to use the chain rule. And in using the chain rule, we can represent u by, remember, cosine of x. So if you use cosine of x, you can rewrite g to be u negative 2. So in this case, we have the u dx. If we differentiate cosine of x, we have negative sine x. And if we differentiate the g du, this is negative 2 u negative 3 using the power rule. So our g prime, which is the same as the g over the x, this is equal to the u dx multiplying the g du. And this is basically negative sine of x multiplying negative 2 u negative 3. So g prime will be negative and negative over here will give you positive. So you have 2 u to the negative 3 multiplying sine x. But we know that in this case our u was cosine of x. So we have 2 cos of negative 3x sine of x. So going back to do our substitution, we have y prime so we have y prime to be equal to our f over here. So we are using this. Our f, we had x. Our g prime is 2 cos negative 3x sine x, then plus our g was cos to the power negative 2x, then our f prime was 1, so if you multiply it by a, you get the same thing. So now what we have to do is to combine both terms to find our derivative. So the derivative of the entire problem is this plus this. So the first one is 4x squared sine cubed x cosine of x plus 2x sine 4x. And the second one, for the second one we had of 2x, so cos inverse negative 3x sine of x, then we have cos negative 2x. So I hope this explains the concept very well and you know how to tackle the problem. So you just have to break the question into two parts. Now let's consider the last question. For question 8, we have y is equal to square root of 7 plus x sec x. So over here, we let our u be what is under the square root. So we have 7 plus x sec x. So if we rewrite y, we have the square root of u. Now, to differentiate this, we have to differentiate this and that. Remember, if we differentiate 7, it goes to 0. So what that we have left is s sec s. These are two separate functions, so you can use the product rule. So for the product rule, your f is your x and your g is your sec s. If we differentiate f, we have 1. If we differentiate sec s, we have sec s tangent of x. So your du dx is basically your f, which is x, multiplying g prime, which is x secant of x tangent of x, plus your g, which is sec of x, times your f prime, which is just 1. So this simplifies to s secant of x tangent of x plus secant of x. Now this root u is the same as u to the exponent of half. So your dy du is 1 out of 2 u. Then if you subtract 1 from 1/2, we have negative 1/2. This is basically the same as 1 over 2 multiplying u to the 1/2 is the same as 1 over root u, which is the same as 1 over 2 root u. So in that case, we can have our dy dx to be dy du multiplying du dx, which is basically dy du is 1 over 2 root u. Du ds, we had s secant of x tangent of x plus secant of x. So if we simplify, we know the u in this case is 7 plus x secant of x, then multiplying it by s sec s tan x plus sec x. So we can rewrite this. So 1 times the whole of this gives us x secant of x tangent of x plus secant of x out of 2 multiplying the square root of 7 plus x secant of x. So this will be your answer. And there you have it, the chain rule, your ultimate tool for tackling composite functions. Keep practicing, and soon you'll be chaining these derivatives together like calculus wizard. Make sure to like, subscribe, and stick around for more videos on Danest Math, because the deeper we go, the more fun math becomes. I'll see you in the next video. Bye.